Hey, welcome back. Some more practice involving quadratics. A lot of the skills that we've been working on lately are going to be put together into a single problem, mainly to figure out if we can sketch their graphs of these parabolas and label a few points accurately. Some of the things we've been doing is solving by factoring. That's going to be very powerful for this and future lessons. And we're going to be able to sketch their graphs pretty quickly. So let's test some of our skills from before and get started. So you can pause and check later or do that right now. So remember, hopefully you want to identify this as something times something equals 0. And remember that it is a quadratic, all right? It has two possible solutions. One of them is when x equals 3, that makes the left side left something equal to 0. And what I like to call the right something equal to 0 is when x is negative 7. So those are our two possible solutions for that quadratic. And remember, quadratic implies the equation has something squared. This one's a little tricky if you're not thinking. It looks like two linear equations, which they are, but they're being multiplied. So remember, this is the same as 0 equals x squared. I'm going to do the simplified form in my head. Plus 4x, that's the sum or the combined value, and then minus 21 is the number that these two multiply to, or the product. So there it is. That's where we see our something squared. Our something squared is implied from the x times x. All right, I won't be rewriting it. Maybe for this particular lesson I will, but for future lessons I won't be rewriting this in this format unless I really need to. All right, next thing, notice that this one is clearly the x squared term is visible, and we have more of it, and hopefully you can think, oh, that looks like some form of something times something. That's the main key to be able to identify that as. How do we, what did we multiply to get the x squared? It was x times x. And now remember that the two numbers combine to a 3 and multiply to a negative 40. I like to think of the product first. What two numbers can combine to, multiply to negative 40? Some possibilities seem like some form of 8 and 5 might work. And that's true only if it's positive 8 and negative 5. You can always check in your head again. 8 minus 5 is positive 3, positive 8 times a negative 5 is negative 40. Therefore, our two solutions are going to be a negative 8, or the other one is a 5. There are two solutions for this quadratic equation. All right, excellent. So there's a little refresher for what we're going to be using a lot. Another thing we will be working on this video and the next one is quickly finding that line of symmetry. Suppose we have x-intercepts of negative 7 and 3. Where's the line of symmetry? We know it's right at the middle, at the midpoint. It's the midpoint between negative 7 and 3, and we know how to find that quickly. Take the average. Negative 7 plus 3 is negative 4. Divided by 2, we get an equation of x equals negative 2. X equals negative 2, and I want to talk about the phrasing of the question. What is the line of symmetry? What I mean by that is, what's the equation of that line? In this case, it is x equals negative 2. What is the equation of the line of symmetry for this one on the right? The x-intercept on the right side is a 12. This one's a negative 6. Right in the middle of those two x-intercepts is the line of symmetry. That's the main idea. So we take the average. 12 minus 6 is 6 divided by 2. Should be a 3. And hopefully you feel comfortable doing both of these in your head. If you need to write a little bit of work down on a piece of paper as side work, that's fine. But hopefully we can both arrive here, all right? All right, great. So let's see how we will be going about this. Suppose we have an equation like number 3, y equals something times something. Again, we know that this is a quadratic, even though the x term is a little bit hidden. Like I said, for this particular lesson, I will be writing them down. Let's expand. This is good practice anyway. Let's multiply this quickly in our head. We get x squared. The sum will be plus 6x. And then the product is negative 16. The two numbers multiply to a negative 16. And they added to a positive 6. Okay, and then for each graph of these, we have three numbers, 3 through 7. We're going to do a few things. X and Y intercepts. Hopefully we already know how to solve for those and label on this graph. Next thing we will be able to label is the equation for the line of symmetry. We talked about point of symmetry. We will figure out where that's missing, coordinates of the vertex, and use all that information to make a accurate sketch of a graph with 5 points labeled. So let's see, let's get started. X and Y intercepts, it depends. We don't know which one's going to be easier each time. So as we do more of these problems, we'll be able to identify what's going to be easier each time. And I'll ask that question. What's easier to find in this form, the original form, that was given is it the X or the Y-intercepts? All right, so let's find out. How do we find X-intercepts when something equals what? That something is when Y equals 0. X-intercepts when Y equals 0, all right? Refer to previous videos if you forgot that idea. X-intercepts when Y equals 0, then the equation turns into 0 equals something times something equals 0, which the first something was X minus 2. And the other one is X plus 8. All I'm doing is rewriting the equation from the original problem and replacing the Y with the 0. And therefore, we know that X equals A2 or X equals negative 8. I kind of ran out of space there. Let's redo that. For each problem, I'm going to try and write fewer steps. But remember that this doesn't represent a ordered pair yet, because X equals 2 and X equals negative 8. For each one of those, their corresponding Y value is 0. So I'm going to get in the habit of writing it as 2 comma 0 and negative 8 comma 0. Excellent. So we have those so far. Now Y-intercept. When do we get a Y-intercept? Now that's the case when X equals 0. All right, so remember that the original problem that was given to us, now we are given an X value of 0, so we replace a 0 here and a 0 here, all right? So I'm going to work with that one. Or the other possibility, since we multiply it out, we can replace a 0 here and square it, and then 6 times 0. Either way, we should get a Y value of 16. So I'm going to skip that for right now, but ask you to verify yourself. In this Y equals negative 16, how can that be represented as a point? Remember that the X value was 0 and the Y value is negative 16. And by the way, having these two options, I myself would have plugged in the 0 in the one in green, because 0 squared is 0. 6 times 0 is 0. This whole thing goes to 0, and the Y-intercept's right there. So the Y-intercept was there already written for us. Look at that. Cool, which is something that I want you to pay attention to. All right, great. In this format, what was easier to find, the Y-intercept or the X-intercept? In this format, definitely the X-intercepts were easy to find. Look at how we can quickly go from this original equation to these without showing it almost any work. That's the thing that I wanted to point out, and we'll start applying that in the next few problems. All right, so there's letter A. That one is done. Equation for the line of symmetry. Maybe I want to start plotting some of these points to see what's going on in this picture. 2 comma 0 is where I will begin. 2 comma 0. This is not drawn to scale, perfect scale, but I'm going to try my best to label some points and use the best scale that I can use in my head. Now, I won't label any tick marks or anything like that. Negative 8, if that's negative 2, negative 8 is probably somewhere here. I don't know. I'm not being extra careful, but that looks pretty accurate to me. And remember, this is a value of 2 comma 0. This one is negative 8 comma 0. And that idea that we applied earlier from the problem number 2 is, if we know X-intercepts, can we find the line of symmetry? If we know these two X-intercepts. And it seems like we created that type of problem for ourselves. What's right in the middle of negative 8 and positive 2? You try and do that in your head as I'm drawing my line of symmetry as best as I can. I didn't like that. There we go. That's a little bit better. And what was this value? It is the average of these two. Negative 8 plus 2 is negative 6. So therefore, this should be X equals negative 3. So there's the equation of the line of symmetry. That's letter B. Okay, we're moving along. Excellent. And then letter C, we have point of symmetry. And our other option, we don't have to do them in this order, is coordinates of vertex. So I know that, let's talk about that for a little bit. I know that the coordinates of the vertex happens when X equals negative 3. Maybe we want to do that first, or the other option is, all right, maybe we want to see more of our picture. We know that 0 and negative 16 should be somewhere right here. I don't know. It's not a excellent perfect scale, but let's say that 0 negative 16. I can always move that somewhere else if I need to, but that looks to me like where it's going to work. So I'm starting to visualize, based on that, some vertex that is going to be here. And remember, it happens when x equals -3. So let's solve for that. I'm going to do some side work. Let's call that letter D right here. And I'm going to say vertex happens when does that occur? When x equals -3. So we're going to take this equation. I like to use the original equation that was given to figure out what the y value is going to be when that x is replaced with a -3. So I'm going to write it as y equals -3 minus 2. Remember that we're replacing this x now with -3, and then multiply that by -3 plus 8. -3 plus 8. Then simplifying that, I'm going to bring this work down here. Remember, so it's still something times something, something times something. The first sum is -3 minus 2. That is -5. And the others, we have to simplify it, is -3 plus 8. What does that become? 5. So then y equals -25. But what does that mean? It's not a location. A location has to be a point. Remember that the corresponding x value was -3. So we're going to write the vertex. I'm going to use V for vertex. Vertex is located at -3, comma, -25. So that one was not very easy to find in this format. We had to think a little bit more, and it was not very hard arithmetic. We have to be very careful with that. So we have 3 points, or it looks like 4 at this point. That vertex is -3, -25, and always check your work to make sure, does my answer fit with the picture that I started to make? And sometimes if that's not the case, then that means you made a mistake somewhere. You should go back and check it. All right, so I'm starting to see that I can connect those dots that make this quadratic. Remember, it was some form of x squared, so therefore it's a parabola that is curving. Because it's positive something square, we know it must be curving upwards. I'm trying my best. You take your time as well. Let's see, I don't like that curvature. Let's try one more thing. Let's do it like this. There we go, that's better. And the other part of that graph should be somewhat a lot symmetrical, but on our sketch, let's do our best possible job to represent that. There we go, I like that. And we have a total of 1, 2, 3, and 4 points labeled. We need one more, and remember that one is the point of symmetry. All right, so point of symmetry, the idea is that this x-intercept is symmetric to that point. So that's not the one that's missing. The vertex is symmetric to itself. Therefore, we're just missing the point of symmetry to the y-intercept, which we need to find now this distance, because that's the same as that distance. And because the line of symmetry is located at x equals -3, that means that this is a distance of 3 2 times in the negative direction, giving us a point of -6. And the nice thing about that symmetry, of those points of symmetry, they have corresponding y values. Notice how that y value of 0 corresponds to this y value of 0. Therefore, this -16 corresponds to this -16 as their y value. But only the x value is changing. Hopefully you remember that idea and can picture pretty accurate parabola right there. We label a lot of things that we've been working on separately and finally put it together in one problem. Give you some time to check that, and let's move on to the next one. Moving on, we know that we have something times something, but be careful now, it's negative something times something. So that does matter. And we'll start to do some work here, actually. Yeah, let's start doing some work. Remember that the first thing we want to find is either x or y intercepts. I'm kind of keeping a mental picture of this. I won't be scrolling back every time. But x and y intercepts, what's easier to find in this format? In this format, is it easier to find the x or the y intercepts? So we can start thinking about that. I think in that format, for sure, the x intercept is easier to find. So I'm going to start with that. X intercept is when what occurs? When y equals 0. There we go. X intercepts when y equals 0. And therefore, we know that 0 equals negative something times something. I don't know. I think for the next few, I probably shouldn't have written this. Okay. X equals -3 or X equals 11. But remember the points are -3, 0. And the other point is 11, 0. And remember that hopefully I'm going to encourage you to go from this equation straight to these points. You don't even have to show all that work. If you can see that visually, it'll save you some time. And I'll start plotting that information. As I'm showing all my work, I think, like I said, I want to show this every time. I guess I will do that in the next one. If -3 somewhere here, let me label that here a little bit larger. -3, 0 is right there. And the other point is 11. Oh, I think I want to do it here. 11, 0. By plotting those 2 points, right as soon as we think that, immediately we can think, oh, what's right in the middle of that? Because it's a key piece of information for these type of problems. And that is the next thing that we want to label, or one of the next things we want to label is that line of symmetry. That line of symmetry happens at the midpoint of 11 and -3. That looks like 11 minus 3 is 8. Divided by 2 is 4. So that line of symmetry is X equals 4. And we know that this is negatives. It's going to be some form of negative something square. So I think the next thing I want to find is the vertex. For me, I'm going to think of the vertex, G. And remember that it was y equals negative. If we were to multiply this in our head quickly, we would get x squared minus 8x minus 33. You can verify that. Take your time if you need to. And then because we have a negative on the outside, if we were to distribute this, then we get negative x squared minus 8x minus 33. I'm sorry, plus 8x and then plus 33. But what I was focusing on the most is this negative something squared. That tells us this quadratic or this parabola curves downwards, all right? So when we find the vertex, we know that it better be this type of graph, something that will go through these 3 points. All right, so keep that in mind. And when does that occur? When x equals 4. So when x equals 4, vertex when x equals 4. Now we have options. Since we wrote all these equations, where can we plug in the 4? We can plug it into this equation, this equation. I still prefer this one, all right? So I'm going to bring that work down here. This is still letter D for the vertex. So vertex when x equals 4, I'm going to take that y equals negative something, but this x now gets replaced with the -4. Or I'm sorry, it was +4. Yeah, +4. Good catch. So 4 plus 3. And then times 4 minus 11. And that y value becomes negative. Remember, it's something times something still. 7 times -7. And then that equals, yeah, this will become, you check your own work in whatever order you want, but this becomes 49, positive 49. And then the point is 4, 49, which is more important, all right? This is the point, not just the y value that we want to be thinking of. So there we go. It is at 4, 49. And that fits our picture very perfectly the way we expected it. It's very nice when all those pieces of the puzzle come together nicely. And I'm going to try not to fight it, but draw as symmetric a parabola as I can. There we go. That's not too bad. It's not the worst. It's also not the best, but that's smoothing it out a little bit more. All right, we're missing 2 points because these two are, the X-intercepts are symmetric points to each other. The vertex already symmetric to itself. We're missing the y-intercept and its symmetric point. Did we find the y-intercept yet? No, I don't think I have done that yet. All right, let's do it here. So y-intercept, what do we know about the y-intercept? It happens when x is 0. So then again, because I already wrote it out from before, you can plug in the x equals 0 to any of the three equations, but I think the easier one and the most convenient, I see it up here, because 0 squared is 0 times -1 is 0, 0 times 8 is 0. This whole thing goes to 0. So you check your own work, and then we get a point of 0, 33. And again, it better fit our picture perfectly, 0, 33. There it is. And last is the symmetric point. So we need to think about that distance, and we know it's equal to that distance. It is 4 2 times. In the positive direction, that point of symmetry, or that matching point, is a 8, and it's matching because what matches? The y value, 33. There it is. 5 points labeled. And hopefully we can speed up a little bit more. All right. But mental picture, if you just need to check, let's move on. All right, and again, you hopefully see this one gets a little more advanced. What's easier to find in this format? The X or the Y-intercept? In this format, not the X-intercept like before, right? So now I think the Y-intercept is the easiest. I think of the idea that I mentioned before, and I'll remind you if you haven't seen it. That's when X equals 0. Why is it more convenient to find the Y-intercept in this case? Because 0 squared plus 0 times 8, this whole thing goes to 0. So then we have y equals 0 minus 9, which is -9. The Y-intercept was right there in front of us. That's excellent. That's convenient to find. So therefore, I'm going to write that as 0. Don't forget that it's a location on an X and Y plane. 0, -9. That was the easier thing to find. What's going to be a little bit more difficult here is going to be the X-intercepts, but not that hard. We've been working on this skill for a while now for this particular reason. And when does that occur? When y equals 0. So then we get the equation 0 equals x squared plus 8x minus 9. Remember that this is not in the form of a perfect square. So therefore, our other method that we've been working up to this point is factoring. So if it's not a perfect square, we got to think, therefore it was something times something, where the somethings are not the same. And we're thinking of sum, we're thinking of products. Two numbers that multiply to a -9 combined to 8, what are those? And always, if you want to think of this one first, what was multiplied for x squared? It was x times x, of course. We shouldn't skip that thinking. But if you want to just write them like without thinking about it like that, that's not bad practice. And -9 possibilities are 3 and 3, but that won't make any 8. So I see a 1 or a 9. And it's got to be +9, -1. So therefore, our X-intercepts are located when x equals -9 or when x equals 1. And remember that they're points, so we will write them as -9, 0 and 1, 0. That's 3 points that we have found. So at this point, we're going to start making that picture, putting some things together. This is 1, 0. And this is -9, 0. Also, we know because those two are some points that are symmetric to each other, that we can find the line of symmetry very easily from that. Let's take the average. -9 plus 1 is -8. Divided by 2 is -4. X equals -4 is where the line of symmetry is located. And that will help us find our vertex as well. Remember that it is positive something square. Therefore, we think what type of curvature? Curving upwards. And that was important to think of the last one. This was negative something square. Train your eyes to recognize one from the other immediately before you plot a point. This is definitely going to be positive something square. So therefore, the vertex will be at -4 comma some y value, which we will find in a moment. But notice how that is starting to fit our picture in a good way. And 0, -9, 0, -9 for sure is going to also fit our sketch on the right side. Let's forget that one. Well, that's the main idea. There it is. That looks pretty accurate to me. Not the most perfect parabola, but it is a good representation of what's going on. And let's see. Remember that we can now label this one as 0, -9. And the last, like I said, last one we did in different order. But now that we know this distance, what is this distance? It is 4. Therefore, this is 4. And therefore, these two matching points or corresponding symmetric points don't have a y value that changes, but only the x changes by a distance of 4 twice in the negative direction. There they are. But remember, this point is not complete. This is the last thing we're going to do down here. So vertex, what do we know about the vertex? In this particular case, it's when x equals -4. So notice how for the vertex, the value of x has depended on the problem. It's not a fixed number like x equals 0 and y equals 0 for x and y-intercepts that we've done before. This one changes depending on the problem, right? So now that we know that, we can plug it into, so one of the things that I see is I don't like to plug in a -4 here and then square it and then multiply by 8. The good thing is that we factored that over here. So I like the factored form better for finding the vertex. So I'm going to write it as the factored form. Y equals x plus 9 times x minus 1, and then make this substitution. So let's find out y value. That is y equals, I'm just going to do it in my head and write the values down though, however, right? When x is -4, what is -4 plus 9? That is -4 plus 9 is 5. And when x is -4, what is -4 minus 1? It is -5. So what that tells us is that the value of y is -25. But the point, so I'll write it as vertex, is -4, comma, -25. All right, that's a 4, not a 9. And this is a 5. Not my best 5, but you get the idea. The concept is correct. All right, I think we have 1 or 2 more problems. Yeah, we need to speed it up because the idea is repetitive, and I'm going to try to write least every time. And I'm trying to get you to think, so you write less too. What is easier to find in this format? Is it the x or the y-intercept? Think about it. And for me, I immediately know this is the y-intercept's the easier form, the easier thing to identify. And this is in this format, and this is when x equals 0. When that's the case, when x equals 0, remember that this whole thing goes to 0, so the y value is -40. 0, -40. Then we have our first point, and we pretty much didn't do any math. We could have done it in our head just by looking at it. That's what I'm trying to point out to you. The x-intercept is going to be the one that takes a little more work in this format. When given to you in this format, we need to let the y equal 0. And remember that 0 equals something times something. I'm just going to go to the factored form. What can multiply to a -40? Combine to a -6. Some form of 10 and 4. Right? And that is when x is -10. And 4 is positive. So therefore, we know the two x-intercepts, one of them is at -4, and the other one is at 10, comma 0. -4, 0, and 10, 0. Like I said, my goal is to show fewer steps every problem, and that doesn't look too bad either. Even though we showed a few steps, one or two steps, we're doing them pretty quickly. That's why we spent so much time on that previous practice. And then I'm gonna start putting the picture together. So -4, maybe somewhere right here. And then 10, somewhere right there. Then we have, I don't know if I like that. Let me give myself more room for error. There we go. That would be better for me. And I know that right in the middle, we think of the line of symmetry. Because there's points of symmetry to each other, we can find that line of symmetry. And what were the values? This was 10, comma 0. This one was -4, comma 0. And the midpoint of those, 10 minus 4 is 6, divided by 2 is 3. Line of symmetry, vertex when x equals 3 in this case. We can go ahead and solve for that now. Whoops. That would be letter C. We say that the vertex for this particular case, when x equals 3. So let's figure that out. Again, it was convenient for me to factor not only to find the x-intercepts, but I like to plug in the 3 in the factor form rather than the multiplied form. All right, so let's do y equals something times something. And remember that we're substituting a 3 for these values of x. 3 plus 4 is a 7. And then 3 minus 10 is -7. So therefore, we get a vertex of 3, comma, -49. And we think, is it positive or negative something squared? It's definitely a positive something squared. So the vertex is somewhere, I don't know, somewhere way down here, let's say, at 3, comma, -49. And if we start to put our picture together, actually, I realized I didn't make it very symmetric. Let me redo that. All right, that looks a lot better. I encourage you to go back and redo some of your points of the way I'm doing right now if it doesn't look, if it's not visually pleasing to you when you make your parabola. All right. When you make your sketch of your parabola. There we go. I like that. I'm pleased with that. We also had solved for this point before. It is 0, comma, -40. All right, it's starting to look pretty good. And then last thing is point of symmetry. We want to know that distance twice, which is 3 2 times in the positive direction, giving us an x value of 6. And the matching corresponding y value is -40. There we go. Look at that. It's pretty advanced and complex in the fact that there's a lot going on, but the skills and the process required to do this is not that difficult. Separate, you know, components. All right, one last one. This was probably a little bit harder for this particular video. So if you understood the first 6, you're in great shape. If you're a little confused about this one, it's fine, and it won't hurt you in the next coming ones. But especially because I haven't done a lot of GCF up to this point. But if you're very familiar with GCF, then you're ready to do this. So what I mean by that is I'm going to rewrite this first by factoring out a -1 from all of these terms. All right, so that's what I'm going to say if you haven't practiced GCF before. And all that means is take the opposite symbol of every term that we factored out from. So what's the opposite of a -x squared? It's positive x squared. So that's why we're doing that. And then what's the opposite of a positive 4x? It is a -4x. And then what's the opposite of a positive 21? It is -21. And then those two are the same. If you don't believe it, distribute this negative to all 3 of these, you will get this back. Okay, that's great. And why did we do that? Is because now we can write this in, and I won't write it yet, but I will ask you in this format. Maybe I went ahead a little bit of what I wanted to do. In this format, what's easier to find, the x or y intercepts? In this format, the y-intercept, again, just like the previous example, that is when all previous examples, when x equals 0. And notice that 0 squared, -0 squared plus 4 times 0, this whole thing goes to 0. Therefore, the y-intercept, again, is very visible and easy to find there. That is 0, comma 21. So that's what I wanted to talk about first. In this format, the y-intercept is very easy to identify still, but we need to do some factoring to find the x-intercepts. That's what I wanted to point out. And I just wanted to point out that, yeah, we need to factor a negative from all of them first. When do the x-intercepts occur? When the y value is 0. And like I said, we want an alternate form for this. So now we can say this is negative something times something. And what is, now we're going to ignore this negative and just factor what's inside the parentheses separately, x times x. and the product is -21. The sum is -4. That better be some form of a 7 and a 3, and -7 plus 3. That will work. All right, so remember that all three of these are the same. All three of these are the same. And now we can say, all right, that helps us out for finding our x-intercepts, because we can say 0 equals negative something times something. But it doesn't matter if this is 0 or this is 0. It doesn't matter if we multiply by -1. This doesn't change our answers. It's still going to be an x-intercept of -3 and another one that is 7. So now we can write those as 7, 0 and -3, 0. Excellent. And next thing would be the vertex. Remember that the vertex occurs, maybe we want to know our line of symmetry first. Yeah, so let's start drawing some of those things that we know. And one of the x-intercepts is -3. -3, 0. The other one is 7, 0. And the line of symmetry, because those points are symmetric to each other, happens right in the middle. What does that look like? Some positive number. Let's take the average. 7 minus 3 is 4. Divided by 2 is x equals 2. And remember from the beginning of the problem, was it a positive something square or a negative something square? Because it's some form of negative something square, the vertex must be somewhere up here to have that curving down type of form. And let's connect some of the pieces of our puzzle. You could always do this in the order that you like, as long as it's all correct. That doesn't matter. But notice how plotting this will make me, or help me, or help us find our line of symmetry much easier. If I don't at least think of the line of symmetries between the x-intercepts, there's other ways to do it mathematically, but I tend to stay away from those if not necessary. All right. So therefore, we can say that, all right, right in the middle is 2, and now we can find that vertex. So vertex will happen when x equals 2. And what is our preferred form? For me, I want to plug it into the factored form. So I know that y will equals negative times something times something. And when x equals 2, 2 plus 3 is a 5. When x equals 2, 2 minus 7 is -5. However you simplify this, you choose the order that you want to simplify it, we get a y value of 2, I'm sorry, x value of 2, and y value of positive 25. There's the coordinates, there are the coordinates of the vertex. And we're almost done. We also have solved before for the y-intercept, 0, 21. And last thing is to complete this 5 points, the distance was 2 twice in the positive direction, giving us x value of 4, y value of 21. There are our 5 points. Oh man, this was a lot of fun. I'm not an artist or anything, but just looking at this gives us a very clear idea of what this very complex equation, this is the algebra expression, this is the picture for this very complex thing. And I don't know, you should be proud of yourselves if this is the first time you're doing it and learning it, in terms of learning it, or the first time you're understanding it. Either way, this was a lot of fun for me. I've done this many times, and it still feels really good to see something really complex represented in a nice visual. All right, guys, this, like I said, I look forward to showing you more of this in the future. Tune in for the next few. All right, have a good rest of your day.